All right. Well, good morning, everyone, and thank you for spending your Saturday with us here at the 2022 Trenton Computer Festival. There are a lot of talks that you can choose to attend, so I appreciate you being here with me this morning. And so this is Introduction to Object-Oriented Programming and Design Principles. So, my name is Michael Redlick. I am. Okay, there we go. There. So this is me. The Petrochemical Research Organization equals ExxonMobil Research and Engineering. Sometimes I believe I could write it down these days, but in the past you used to have to get document clearance just to actually state that in writing. But I think that's changed, but just to play it safe. But I've been with the company 32 plus years. I'll be looking to retire within the next 2 years or less. But in my spare time, I do quite a bit in the Java community. I write for InfoQ in the Java space, and I serve as the lead editor these days since July of last year. I've been running the Garden State Java user group. I should state more accurately, we have a leadership team for the Garden State Java user group, which used to be called the ACGNJ Java group, which I started in 2001. And we have 21 years now of having meetings, and so we have a great leadership team. Barry is one of them. He's one of the co-directors. And then I'm a member of the Jakarta EE ambassadors. And this started out as the Java EE Guardians when Java Enterprise was stagnated back around 2016, 2017. And then when Java was, or Enterprise Edition was moved over to Eclipse Foundation, it became Jakarta EE. That's a whole long story in itself. Could be a whole another presentation, but so our Garden State Java group, one of the things we do in the Java community is that we are part of the Microprofile working group. Microprofile is a set of specs for microservices-based applications. And we also have adopted the Jakarta EE NoSQL specifications, which is one of the specs among close to 30. So that's a lot of what we do as part of the Garden State Java group. We're a nonprofit, and so we like to be involved. So all right, so the objectives for today, we want to talk about object-oriented programming and then object-oriented design principles, and we'll go into some live demos. Okay, so OOP. All right, there's a number of languages out there that are object-oriented, and you can see the list right there. A lot of them, I'm sure you're familiar with C++, Java, of course, well, Python, Simula, then, I'm sure this is just a small list, but I don't know if anybody is old enough to remember things like Eiffel or some of these other ones, and Smalltalk. So, but they are object-oriented languages. So object-oriented programming is a paradigm, and it's focused specifically on objects and data itself. It's a different mindset than using a programming language like C or BASIC or even Pascal, because those languages are more centered around an algorithm. And objects are identified as to model a system. And we'll get into a little bit of that. And they're also designed to interact with each other. And that's where the design patterns come in and things like that, which we'll touch on a little bit later. Okay, so yeah, so here's some of the basics here. So this is a juxtaposition of procedure-oriented and object-oriented. So procedure-oriented would be like, say, C, Pascal, as I mentioned earlier. And that's usually a top-down or bottom-up design. It's considered a structured programming language and centered around an algorithm. So for example, you deal with how you want to do some business logic, for example, and then then you worry about how to do input from the user, presenting the output, etc. And it's a way to identify tasks and how something is done. On the other hand, in the object-oriented space, you identify those objects to be modeled. And they also concentrate on what the object does and hide how the object performs its tasks. And this is all part of encapsulation and abstraction and things like that. You identify behavior. So each object has its own behavior once it becomes, from a class to an object. And we'll get into all that. So one of the first things is an abstract data type. And this is a user-defined data type. So we're all familiar with, integers and floats and, strings and things like that. Well, this is one that you, the developer, create. And you do this through the class mechanism and to, create whatever you'd like to do. And there are functions or methods, and those two terms I'm going to probably use interchangeably. Methods are generally tied to the Java programming language by default, and then functions can be referred to C++, all right? But, you want to do this without giving away how, how it, abstract away the internal representation. That's essentially what you do. That's part of encapsulation. There's interface and implementations. An interface is something provided by the abstract data type that allows access to data. So you, the developer, say, okay, our users of this application are allowed to, get values and potentially set values. And then things that are more private, you won't let the users access them, all right? For whatever reason, okay? The implementation is the underlying data structure and business logic within there. So, for example, that could be something like a linked list, or whatever data structure you have, a vector, an array, and on and on. So the terms class and object are used interchangeably quite a bit. However, there are notable differences. So the class, which we'll get into, is defines the model, declares the attributes and behavior, and then is itself an abstract data type. An object is alive now. It's an instance of a class, and because of those attributes you declared, it has state and has behavior. And you can have many unique objects of the same class. So you have a car class, right? And it has those attributes, has the behavior. So think of attributes as nouns, so you have things like the color of the car, the tires, the size, that kind of stuff. The behavior is, get the color, or, move into park or move into drive, those kinds of things that are more verb oriented. But then you can have car 01 as a variable with parameters. You can have car 02 as a variable with different parameters. So that's the difference with those two particular terms. And the four main attributes of object-oriented programming you can see listed there as data encapsulation, abstraction, inheritance, and polymorphism, and we'll go through those. So encapsulation is very important because it separates that implementation from the interface. It's a public view of the object, but the implementation is private. And that's why I mentioned earlier about the difference between the interface and the implementation. And I also mentioned earlier that access to data is only allowed through a defined set of methods for various things. Abstraction is a model. And, I'd like to use the cartoon you see there about the infamous, well, not infamous, but a black box, and, there's some input, and, you have no idea what it does on the inside of that box, and then there's some output. But you define that data type by its functionality as opposed to its implementation. So manual transmission of a car, well, how do you use that? Well, you got a clutch pedal and you have a shifter, right? But unless you're a mechanic, you don't necessarily know how that manual transmission works as the driver uses it. Inheritance is used, quite a bit in object-oriented programming, and it can be actually, as I'll mention later, could be an anti-pattern, as they would call it, if it's used too much. But the way you would use this is you can define a new class as an extension of a previously defined class. Okay, and it's called inheritance because that new derived class inherits everything from the base class, and it has this is-a relationship. So baseball is a sport, Pontiac is a car, so on and so on. So when you define your classes, sport would be a base class, and then you can extend that to create the baseball class. And we'll show how that all works out. Polymorphism is from the Greek meaning many forms. And this is basically a way of having a function respond differently to objects within a family of classes, right? Like display, for example. You can actually display content differently from sports class versus the baseball class, all right? All right, so last 10 minutes or so, I've been talking about this, and I'm sure it's a fair question to ask. So what? So these are the advantages. So an interface can, and I highlight there, should remain unchanged when you improve the implementation. And by that I mean to create a linked list, which I think is the best in the world, right? I put it out there on GitHub, everybody uses it, and documentation and et cetera, et cetera. We get all rave reviews on Twitter and all the GitHub stars and all that. But 6 months down the road, I'll say, you know what? I bet you I'll get better performance if I change X, Y, and Z. That's all well and good. However, you better not change the interface. So any methods to get data, set data, and things like that should be the same, because what's going to happen is you're going to have to change your client code that uses it if you change the interface. So all of a sudden, everybody's going to be mad at me and not use my product anymore, even if it's free. So that's very important. It does encourage modularity in application development. A lot of the methods are short, and because of that, it's more easily maintainable. And of course, you can reuse these things as well. It's an emphasis on what and not how. Questions so far? Okay, I don't know if there's anything in the chat or not. Can't really see it in this mode. But just unmute yourself and ask. Okay, so unless you're a Zoom bomber, then you can't. Okay, but all right, so we're going to talk about classes here. It's a user-defined abstract data type, and it's based on the C struct mechanism. If those of you who are familiar with the C programming language, you will remember the struct. Well, but it's a little bit different because a class has a way to construct it called a constructor, a way to destroy it with the destructor. And then you have a number of data members and member functions or methods that put everything together. In C++ and Java, there are multiple ways to instantiate or create live objects from those classes. So a couple of examples here. In the C++ world, you can say sports with no parameters with the void keyword. That does not fly in Java. These three are all C++ essentially. An array of char, or a pointer to characters, and then int. You can create that if you're modeling, with the team name and say a set of wins and losses. And you can actually, do the same thing But the reason I have this here is because if I wrote out char star float int, integers and floats can be, converted automatically in the background. The compiler will do that, and you will get a compiler error, all right, saying that it's ambiguous. So, however, you can trick the compiler and say and switch the order, which generally you don't want to do in this case. But my point is that you can change the order and then placate the compiler. Just one example of that. Scope resolution. It's the : operator, and this is a way to define or to provide scope for a class in C++. If it's a sports class and you want to refer to a method within it, but then if it's baseball, for example, it might be slightly different, then there's a way to resolve that scope by using this operator. Abstract classes generally have a declared method in at least one. And basically what that is, it's declared and then defined later on. And that's like the interface keyword in Java and the things like this. So it's a little bit different between the two languages. The pure virtual member function in C++ is this very strange looking assignment using the virtual keyword, the return type, which in this case is none, so it has the void keyword in there, and then a draw with the parens that takes no parameters, and you assign it to 0. I remember the first time seeing this and like, wow, what the heck is that? And then in Java, you have the abstract keyword and the very similar, I wanted to make these the same. So here's inheritance that I mentioned earlier. You can see this, the base class called sports contains a team name, number of wins, number of losses, and then in this case, we'll calculate the percentage, the winning percentage based on wins and losses and all that, right? So baseball, football, basketball, they are all derived classes, all right? They extend from sports. So baseball, as you see, is empty. Well, that's only because it already has everything from sports within it. Now, if you notice in football and basketball, there is an additional member in there called of type int called a tie, because baseball, they don't have ties, right? Familiar with baseball, they'll play 50 innings before they declare a winner until somebody breaks the tie. But in football and basketball, that's not the case. So this is where you can say, where football can get everything from sports, but then include the tie member. All right, so here is where you make a class live in the C++ world. Okay, so you would have the type called baseball, as you saw in the hierarchy in the last slide. So just like you would say int I, this is baseball Mets. In this case, Mets. It could be whatever you want to call it. And then I'm passing in this case, I'm creating an object that has a team name, the wins and losses. Now, to get access to that, you would define a getWin method. And in this case, it would return 97, because the assumption here, of course, is that the order in which things are assigned in the constructor would be the number of wins in the second parameter and the number of losses in the third. Let's see, that was static instantiation. Yes, okay. Dynamically, you would, since C++ has pointers, it looks a little different, as you see. So the Mets variable is a pointer to type baseball. So baseball star Mets. And then you use the new keyword, and then you repeat the baseball, and then everything else is the same, as you saw on the last slide. However, since it's a pointer, now access to these public member functions is a little different. There's this arrow notation. So instead of the mets.getWin, you would do this mets arrow, using the dash and the greater than symbol, and then you would get the same, get the same number back. In the Java world, it's just one. It's very similar to the dynamic instantiation in the last slide in C++, except there's no star because there's no pointer. And then you'd use the dot notation to get the value of 97. So it's a little bit simpler, and that's if you stick around for the intro to C++ talk, Java was based on C++, but James Gosling, who invented Java, didn't want all the headaches of memory management and all that stuff, and that's still true today. So more on that in the next session if you decide to stay. So, and by the way, I have all these on my personal website. You can download the PDF versions of these slides. So, of course, memory management in C++ is something that is very important. So in the static way of declaring an object or creating the object, right? The object itself will be deleted automatically when it goes out of scope. If you're out of the function, then it just gets cleaned up. However, in the dynamic way, you would have to use the keyword delete. So you see the difference right there. It's a required call. Otherwise, it does not happen. Okay, so it's very important. So this is a way, the delete keyword is a way of, removing those objects that are created via a pointer. In Java, it's automatically done for you. There's a garbage collector, and there are different kinds of garbage collectors in the Java, Java programming language, and that itself is a very complex way of handling that. That itself is a presentation or so. But you can explicitly call the garbage collector using the system object and then the GC method. But what happens there is that the garbage collector will acknowledge that you called it, but it may not do it right away. And I don't know if that's necessarily different depending on the GCs that are out there. Some of the the newer versions of Java have newer garbage collectors these days. All right, we got some principles here, and we got about a half hour left. So, no questions yet? Okay, cool. All right, design principles. Okay, underlying principles for creating flexible designs, as you see underlined there, that are easy to maintain and adaptable to change. So those three phrases that I underlined are very important. To me, understanding the basics of OOP isn't enough because of some of the things that can happen by using object-oriented programming. And that's why these design principles came into play. And there's a whole book on design patterns that are based off of these principles. There's a couple of books, by the way. I'll mention them later. All right, so some of them here, I'm just going to scratch the surface on some of these. You can see them here. Encapsulate what varies, program to interfaces and not implementations, favor composition over inheritance. This is an important one. Classes should be open for extension, but closed for modification. And this is the decorator pattern, which I think is quite fascinating. Strive for loosely coupled designs, because I remember earlier objects interact with each other. And then a class should have only one reason to change. So that's just some of them right there. So the first one, encapsulate what varies. You identify and encapsulate areas of code that would vary, right? Because, let's see, this thing's in the way here. Because it can be altered without, encapsulated code can be altered without affecting the code that doesn't vary. Right? And then this one here forms the basis for almost all of the original design patterns, and there are 23 of them. from the original book in I want to say 1994. All right, so if you take a look at this code here, all right, I don't know if you folks are familiar with the Java language or not, and I don't know why I have this thing coming up here. This happened yesterday. My mouse actually decides to, but that's okay. Well, so anyway, so here's an order cars class, all right, and then within it, we have an order car with a lowercase o method that returns type car. Now you have to, in this case, you have to envision that there is a separately defined class called car, all right? And then, so in the object, I'm sorry, in order car, it takes as a parameter of type string. Now this is all Java now. That is a model, it's a variable name model. Now we create an instance of car, and then we have some if, and then, if else statements here. So if model equals charger, then let's create a new Dodge, which you can envision the sports and baseball and, that relationship that Dodge is a car, in this case, Chevrolet is a car, and so on and so on. All right. So based on what is being passed into the order car method, that will dictate what subclass or or derived class is going to instantiate, for that car variable. And then after all that happens, right, then you're going to call the build car method, the test car method, and then the ship car method to do just those things. So what do you envision as being the area of this code that changes? Anybody? Just unmute and
add new models.
the different models, right? Exactly. So how many cars are out there, right? So you can see this whole section of if and else's. I mean, this is kind of crazy to have all this, here. So what you would want to do is take this part, all those if else statements and put that elsewhere. The part that those three methods, they're not going to change because that's what that's what you're going to do with them afterwards. So, thank you. All right, so we'll do a demo here, and this gives me a chance to get my mouse back and shut this off. Okay, and this is the factory method. I'm going to find here. Okay, and clean up some of this here. Okay. Get some real estate back. All right, this is not the one I want to demo. I'm going to do the factory method. Okay. All right. So factory is one of the design patterns that is out there. And I have, in this case, all my Java code here, I have a Buick. We'll just look at one of these. The rest are going to be very similar, for time. And make that a little bit bigger. All right, so a Buick extends car, all right? And then we're going to assign to it the make, model, and then the manufacturer, right? Very simple. So that, the model is assigned to, from type. And I should go to car first, that would help. Okay. So you saw on the slide, the last slide before we started this. Come on. Okay. So here's these are the elements here, or the members, right? Make, model, and manufacturer. Notice this is an abstract class. Okay, you got the class keyword. Public has to do with visibility. We'll get into that in the next talk. All right. And I seem to have probably made a mistake in making this abstract because none of these are just declared. So I apologize for that. I got to reevaluate. This is old. This is old code. And if you look at the comments up here, August 14th, 2006, Barry and I collaborated on a number of these articles. So, but anyway, you have here the methods that I mentioned earlier: test car, build car, ship car. And then you have these getter methods: get make, get model, get manufacturer. And that corresponds to make, model, and manufacturer. This is a Java thing known as Java beans, where you have a get or a set that precedes the member itself, but then you capitalize the member in the name of the method. And very simple, look how clean this is. All right, in the get methods, you're just returning the value of make, the value of model, and so on. Okay. You know, why that's abstract, I don't know. And then Buick, of course, I just mentioned, right, will, you know, this is a constructor, right? Buick extends car, so that's how you establish the relationship between base class and derived class. So car is the base class, right, using the extends keyword. Chevrolet, Ford, they're all going to be the same, right? So we're not going to go through those. You can look at the GitHub repository later at your leisure. Let's see. There's an order cars method. So let's see. There's a car factory. Okay. All right, and in that we're going to no, call it abstract here. Oh, all right. So we have a create car method. Now this is abstract. Okay, so yes, this create car is has no defined body in it. There are no open and closed brackets or curly braces in this case. All right, so that is abstract. And by the way, I need to say for that this code is old. I bet you some of this might be a little bit, you know, could be a little bit outdated. All right. So this is what's the beauty of IntelliJ IDEA here. So, but I think we're in good shape. And I know this will run with JDK 16 and 17. All right. We have an order car method here that takes as parameters make and model. And you saw the warning that make is never used. So, all right. But we're going to create the car. Okay. And we're going to just put out some, you know, text onto the screen. Right, we're going to call the build, the test, and the ship, and then return that car itself. All right, and then we have Ford factory, which extends car factory, and this is where you change out all that code that varies. We separated it out into other classes. All right, but it's still going to be a big list, but it's not one big list. Ooh, what happened there? Okay. All right, so you'll see here Fusion Mark IV, okay, and then in General Motors, you know, I got Lucerne, Corvette, GTO, View. Of course, anybody knows, but you know, Pontiac is gone these days. But I've had a few Pontiacs over a number of years since I've been driving. But and we have our orders car class. Oh yeah, this is the main application. All right, so we create our factories. And then we can order car for the different types. GM factory we'll call order car for Pontiac, Ford factory for Mercury, and so on. So if we run this, okay, let's see, let's do Gradle. I'm using Gradle as a build tool. Clean, compile, and then, oops. Of course, I was testing this earlier and it was working, but you know, live demos tend to do different things. Oh, there we go. Okay, so good. So you know, put this out to screen, and it has, you know, all the different things that we, you know, building the Pontiac, we're building the Mercury, building the View, and so on and so on. So that's, you know, a short test on that. We got 20 minutes left, so let's go back to the screen here. You know, since we have the Ask Me Anything session later, if you have any more detailed questions about this, I'd be more than happy to answer them on that.
You've muted yourself. You've muted yourself.
Yeah, Mike, we can't hear you.
I'm having issues with my mouse in full mode here. I don't know why. This is something, this happened a little bit yesterday as well. Okay, so program to interfaces, not implementations. This eliminates being locked into a specific implementation. Okay. You generate or declare generic behavior, and concrete classes implement methods in a defined interface, from an interface. We'll see how that works. All right, so here are two simple classes, cat and cow. Okay, and if you're a yoga fan, this will sound familiar. So we have public class cat, and then a string, a meow method that returns type string, and it returns, the word meow, just as a simple thing. And the same thing with the cow class. So when you use these, right, in the main application would have in Java and C++, you have a main method that's your entry point into the application, right? So public static void main is always used as the enter point in Java. And we create the new cat object, and then we put out the cat says, and then cat.meow. That's how you get the value of meow back. And similarly to the with the cow. And that's the output that you see at the bottom of the slide. Easy enough. What's wrong with this? Well, we should have some generic behavior, because you're tied to, cat.meow and cow.moo, but you want to declare some more generic behavior. So all animals, they all speak, right? So let's add an interface called animal. So this thing is called animals. So that's the distinction there. And as you notice, there is a speak method that is just declared. So it has to be implemented by somebody. But you notice the interface keyword that I have in green. Okay. So now, and there's a couple of ways you can do this, but I just wanted to, add the stuff in green that you see there. So cat implements animal, as opposed to a derived class extending a base class. This is the implements keyword, and then you have to implement the speak method. And in this case, it's going to call meow that's defined from the existing class from earlier. However, you can just say the speak method return meow. But again, I just wanted to demonstrate, how we just changed everything. So, you can do this whatever way you'd like. And similarly, you can see that the, with the cow class itself. So how that changes now is because you can actually write animal type cat equals new cat. And the same thing with cow. So now it's more generic, because cat is an animal, cow is an animal, right? And then you just call the speak method, and then the output, which I just realized doesn't have the cat says and the cow says, but you get the idea, meow and moo. But you're using one method that's just generic for all that. So that's in a simple example, that's how you would use interfaces and program to interfaces, and not the concrete classes. Because animal's an interface and cat is a concrete class. All right, favor composition over inheritance. So I mentioned this earlier, that has-a can be better than is-a, right? And this comes about by excessive use of subclassing. And you can change a behavior through composition as opposed to the inheritance, and then this can happen at runtime. Okay. And another principle is classes should be open for extension, but closed for modification. And this is from the book, from the Head First Design Patterns. And they always said, come on in, we're open. You can extend the class to add new behavior, but we're closed because the code must remain closed to modification. We'll see how that works. It's pretty cool, actually, the decorated design pattern. So this is a simple hierarchy, okay, of a beverage. House blend, dark roast, decaf, and espresso. However, you can get a house blend with mocha, or you can get it with sugar or no sugar, whatever, but it kind of looks like this. So now you have to, because of, subclassing, you have a house blend with mocha, house blend with caramel, and so on and so on. And you can see how messy this gets in a hurry. Okay. The refactored design is the decorator design pattern. And this is where you have beverage as the base class. And then you have the decorator, and we'll call it the condiment decorator. You can call it whatever you'd like. In this case, we're decorating with condiments. And then you have your original 4, in this case, derived classes. But then you notice that the various things you can add in condiments are derived off of condiment decorator. So it's a lot more clean and easily read by someone else. Okay. Sorry for loosely coupled designs between object and interact. You always want flexible applications that can handle change. Okay. And changes to one object won't affect the other, and object can be used independently. Here's the publisher subscriber model here. You see that here's a weather station that has inputs from a temperature sensor, humidity sensor, and pressure sensor. The data object will pull from that weather station and then display on whatever device is requesting it. So we got the demos for that. What time is it? 10:56. All right, let's we can do this relatively quickly. Okay. All right, so we need to go. Let's do decorator first. In this case, my decorator example is actually has to do with an employee. Why isn't it going there? I did say decorator. Thank you. Okay. In this case, we're doing the employee and different types of employees. So we have a employee class. All right, that's generic. This one is truly abstract because the get responsibility method is just declared, and you have getters and setters tied to the title and the name. Okay, and then here's a set name method, and this is where I mentioned earlier, where you can allow access to change things. Okay, so in this case, you want to change the name, and this is a no pun intended, I guess. This .name refers to the name up here, and then this name refers to the one on the right-hand side of the assignment. So that's just some shorthand you can do instead of using different variables. All right. One of the things I really hated is people would use underscore variable name. I'm like, I don't know. That's just me. So anyway, so here's the employee decorator. And basically it extends from employee that I just showed, right? And it has a get title method that's abstract. All right, so somewhere along the line, these things have to get defined. So let's, so since I'm a research tech, we'll cover that, all right? So research tech extends employee. This is similar to the decaf extending from beverage, all right? So I have the set title. Super refers to the set title method in employee, because of the hierarchy. All right. So this is a default constructor. This is a more of a primary constructor. So you're actually, passing in some parameters. All right. We'll set the title to that. Set the name. Okay. And then the responsibility method here just says acquire laboratory data. Now that's going to change on the fly, as you'll see. Now, administrative assistant and principal investigator are very similar, okay? So we can save some time on there. So, all right, where I work, everybody has all these extracurricular responsibilities, right? So, for example, I'm in the emergency response team, all right? So I do all that stuff for hazmat and everything else. But, at one point I was a computer security officer. So, so people have these things, and we don't have blood drive canvassers anymore. So I may have to update this at some point. But in any event, you get the idea, right? So here's where, similarly to the milk and the mocha extending from from beverage decorator, this is the same thing where a computer security officer extends employee decorator. All right, so in the constructor, since you're passing in type employee, again, this goes back to the ISA relationship. We hold an instance of an employee. All right, this is the HAZA part. All right, and then we assign that to here, right, through this constructor. You get the title. Now you notice here, we return employee. So this is already defined somewhere. All right, so say it's a research tech, and research tech get title says acquire laboratory, or research technician, I'm sorry. It's the responsibility, that's different. We can get the name of that person, and then plus security officer, computer security officer. And with get responsibility, all right, in the research tech, it's the research technician is, it says acquire laboratory data and handle computer security issues. All right, so you can see where this changes on the fly. Now, it's all wired together in the main application. And we'll just go through one of these. So, all right, so we will define an investigator, principal investigator, and we'll call him Gustavo Cari, who's actually a person that I know. All right, so we created that. Now you can use this variable to say new safety captain. All right, so that gets reassigned. You're passing it in. You're reassigning that behavior and value for that, and then you write out get title plus responsibility include get responsibility, which has all that extra stuff. All right, and the same thing here for myself and for another person that I work with every day. All that. So let's see how this runs. Oops. Oh yeah. Okay. Okay. By the way, oh, there we go. All right. So you see here. All right. Principal investigator Gustavo is also a safety captain. Responsibility include analyze laboratory data and perform quarterly safety inspections. So this is all done on the fly without changing anything. You're just you're reassigning in real time, but you didn't change any code in order to do that. So, and yeah, but that's the thing. And so all the output is formatted the way, in the in here, so. All right, what we got here? I have here 1103. All right, I'm gonna save the other one, for you guys to investigate if you want to take a look, just to save some time. So I apologize for that. Let's see, it's getting close, and if anybody wants to go anywhere else, I don't want to hold you guys up either. So, all right. Yeah. There we go. All right. Yeah. Sorry about that. I knew this would be a lot. All right. Okay. And the class should have only one reason to change. All right. Sometimes, developers can program in too much responsibility. All right. And there's something called cross-cutting concerns. And this was something with aspect-oriented programming where you can have a series of classes and you cross-cut through, it's too many things to maintain, in each of those classes, for example. All right. I just wanted to talk about some local Java groups and also, some resources for you before we end. And so first and foremost, as I mentioned, the Garden State Java user group. We have an awesome leadership team that includes 4 directors, myself, Barry, who's on the session here, at least I think he still is, and then 2 others, and then we have 3 leaders, and we have advisors as well. So We rebranded October 1st, 2020. We went off on our own, and we're a non-for-profit organization. The New York Java SIG, they're right across the Hudson River in New York City, and it's facilitated by Frank Greco. And then, Barry Bird is one of the coordinators as well for that. And on the opposite side of the Delaware River, we have the Philadelphia Java Group, or otherwise known as Philly Jug. There's a series of folks that run that one, led by Paul Burton. And then Jersey City Java Group. I haven't seen too many meeting notices from them, but in any event, they would meet at various times as well. I'm hoping this group comes back. I still leave them on here. I mean, there was the guy Dan Patsy moved west and whatever. I don't think I don't know at this point. I don't think they're coming back, but that's unfortunate. All right, so further reading. I wanted to mention the Head First Design Patterns. These are awesome books, and the style of writing and their examples and everything is just, I can't recommend them enough. The original book by what they call the Gang of Four came out in 1994. It's very dry. It's informational, but very dry, I will say. But still, it's a useful, those define the original 23 patterns. And I just touched on some of them today. And so, yeah. Some resources, javasun.com, which I always like to put on there because Oracle bought out Sun Microsystems in 2010, but, yeah. But anyway, Head First Labs has the books. There's other things like the Meteor book. Meteor is a JavaScript a framework. And then, Invented Mind and atmospheremeteor.com. Contact info for me this is my email address, my Twitter, my personal webpage with a portfolio endpoint. And this is where you can find a number of my, ready to go presentations. I did made some slight changes to this talk and the next one, and even the one from yesterday with the Jakarta NoSQL and MongoDB. My GitHub page is here. If you send me email, I can point you to the right GitHub repository, off of this, and be more than happy to share that with you. Since it's 11:07 Eastern time, having one of these right now is a little bit too soon. But again, in the spirit of having a, ending a presentation, is the reason why I put that on here. So, with that, any other questions? I'll stop sharing here. So,
yeah. Hey, Mike, can you go back? Can you go back to the slides on the user group? I think I might have missed those.
Oh, sure. No question. No problem. Yeah, if you want to take a picture, for example. Well, there's two slides on that. So,
okay, just grab a screen capture of this one.
Yep, and then the next one.
Let me switch back. Yeah, this is okay, great.
Yeah, and there are other good groups too that might be presenting virtually. Kansas City Jug and Chicago Jug, and we have a section on our website that we have friends of, or Garden State Java groups. So.
Okay, are all the meetings for the Garden State group, are those all virtual or?
We have been, yes, since we organized during the pandemic. We have been virtual, ever since, and we originally agreed to be virtual through the end of March, this month. However, we have Venkat Subramaniam next month. That will still be virtual. We're carefully trying to do a hybrid approach when we go back in person. We normally meet at Drew University in Madison. If anybody knows where that is. Yeah. Yeah. So, we've had so many people from around the country, around the world join our meetings, and we don't want to lose that. So, But yeah, so stay tuned for that. If you're interested in being on my distribution list, you can send me an email. You can send, info@gsjug.org. With that information. And I send like 3 or 4 emails a month, so it's not terrible.
Okay, yeah, I'll send you an email. I'm very interested. I'm very close to Drew.
Awesome. That's good. Yeah, but in the meantime, we'll get together and we'll figure that out. Our group meets once a week, and we just do a lot of behind the scenes stuff. And so, we keep us pretty busy.
Michael, Daniel, quick question. What types, I'm new to object-oriented programming, what types of programming problems are not really suitable for object-oriented programming?
So, wait, say that again. What?
Sure. What types of programming problems are not really suitably solved with object-oriented programming?
Oh, that's wow. Are not suitable to, like, in other words, they're hard to solve. Is that
right? There might be other programming data organizational methodologies that are better than object-oriented programming for that class of problems.
Oh, so all right, let me see if I understand. My speakers are a little, this is an older Mac, and my speakers are a little bit crackly. So in other words, are there better languages out there, object-oriented programming language, to avoid some of these problems?
No. In other words, what types of problems are not really good for solved by object-oriented programming? Maybe using dynamic approaches as opposed to OOP.
I think I understand your question. Yeah, I'd have to ponder that one. Why don't we talk offline on that? All right, because that's going to require some thought on that. I don't know, Barry. I see Chuck here too. I don't know if you have any thoughts on that.
Yeah, I think when your problem doesn't have a lot of state, you don't need classes. One of the things that happens is when you start doing object-oriented programming, you think everything's got to be a class, and so you start making classes out of everything, but they don't hold any state information. And basically, a class with no state is just a collection of static methods. So at that point, it doesn't really make sense to use that sort of framework to solve your problem. So I can't tell you what type of problem, but if you're not using state within your objects, you might want to reconsider. Now, I know in Java, you have to have all your methods in some sort of class.
Yeah.
Right? Isn't it like .NET? Yeah. So in that case, you've got to stick them in there, but then your class hierarchy gets a little bit different. It's more functional. It's not object-oriented.
Right. Oh, yeah. So that's a whole nother thing. But there's functional programming out there too. That's a whole nother area, and that's why I was kind of wondering if if one language that's object oriented is better than another in terms of this kind of thing. So, but yeah, that's an interesting question. Wow, guys are throwing us curveballs here.
It's 2 cents.
Yeah, let's. We can talk about this later at the Ask Me Anything session. There was so somebody had asked real-time problem ? So yeah, like I said, let's ponder that a little later. I know it's getting late. I don't know when the next session starts here.
11:20.
11:20. Okay, that's 6 minutes. So. Yeah. All right. First of all, thank you very much for spending your time for this session. I'm going to take a quick break. For some reason, I had a thing about my disk being full. I don't know why, but try to address that real fast. So I will see you in the next session for those of you who want to join, and we'll talk to you then. And thank you very much. I appreciate the time here with us today. So, thanks.